So we covered 2 in 40 through, what was it, 50 before we finished on Friday. Because I'm trying to remember which 2 we did. Because we did 41 and 44. Are there any questions on 40?
Is this our one?
If there's any questions, but I don't think we'd be upset if we didn't.
Okay. So with 40, what we're needing to do is rewrite it so that the bases are the same. So we can rewrite 8 as 2 to the third power. 2 to the third. Then we can multiply through, we can distribute through the 3 through. 3 times x would be 3x, and 3 times 7 would be negative 21. And since the bases are the same, it means the exponents need to be the same also. And at this point here, we can solve for the value of x. So for this one here, x is 36. Mm-hmm. And guys, if you are needing an extra copy of the review sheet, it is in Google Classroom. I've uploaded a copy of those there.
I just forgot.
We good? 42 or 43? Since the bases are already the same, yes? We can set the exponents equal to each other. Then we can solve for the value of x. We can add 35 to both sides. 5, 6, 7, 42 is equal to 2x. Divide both sides by 2. And we get that x is equal to 21. Any questions on this here? Questions on 43? Because I think we have 43 and 44. Because I think we did 44 on Friday. And 43 is going to be the exact same as 44. If we do have time, we'll come back and look at it, because I do want to make sure we get to some of the others. Questions on 45 or 46? Which one of those do you want to look at? Huh? We'll come back to that if we have time, because we did 44 on Friday. So 46. So we have this here. I'm going to move the 38 over a little bit. Because once we want to, if we have a variable in the exponent, we want to get it out. Now we want to make sure that the base, so 11, is by itself, and it is, because there's nothing being added to it, because we exclude the exponents, and nothing being multiplied by it. Because once we get it by itself, we can apply log base 11 to both sides. Because log base 11 of 11 would simplify out, leaving us with 6x plus 2 is equal to a log base 11 of 38. And then once we get this here, we get the variable out of the exponent, we can get solved for the variable. So the first thing we can do is subtract 2 from both sides, which will tell us that 6x is equal to log base 11 of 38 minus 2. Then we can divide both sides by 6, which tells me x is equal to log base 11 of 38 minus 2 divided by 6. Now I would make sure to write that out on your test whenever you get it solved before you plug everything into the calculator. Because just on the off chance that you don't type this in 100% correctly, if you have that correct, that is what the answer is, but get the wrong decimal form of it, I will still take it. So really at this point here, we could just type this into the calculator. Negative 0.081. Yep, and that would be it. So just in case you type this in wrong, because if you use log base in the graphing calculator and forget to put that parentheses to close in the 38, it would give you negative 0.54. It would give you a completely different answer. Because if you don't put this parentheses, both parentheses around the 38, it's going to think it's 38 minus 2 inside the log. It'll give you a different answer. Any other questions on this one here? Any other questions on 46? Are we good with that one there? Because the other one with the 7, instead of using log base 11, we would use log base 7. So any questions on 45 or 46? 45 or 46? Would you go with 45 and 46? Yes? Questions on 47, 48, 49, or 50? Mm-hmm. So all of these are going to be the exact same because the log on both sides, we have log base. They're both the same log, yes? Now, according to our one-to-one property, if the logs are the exact same, what's inside has to be the same as well. Really, what that's coming from is if I apply 2 to both sides, well, log base 2 to the log base 2 cancels. 2 to the log base 2 cancels, yes? So all we're left with is x squared minus x minus 6 is equal to negative x. What's inside the logs? Because the logs are the exact same. Well, it is a quadratic. We do have an x squared term. So that means I need to get everything on the same side of the equal sign. So I can add x to both sides because negative x plus x is 0. Well, over here, negative x plus x is also 0. So we have x squared minus 6 is equal to 0. Now, unfortunately, we can't factor this, but since we do have an x squared term and a constant term, we don't have a middle term there, we can move the 6 over. We're using the square root method, because that'll tell me that x squared is equal to 6. And if we square root both sides, we can say x is equal to plus or minus the square root of 6, because I can't simplify the square root of 6 without turning it into a decimal. Now, for those of you who've already looked, there is only one answer to this. So any questions before we go back and check this? Check these answers. So we cannot have a negative inside of the radical. It has to be positive. So I'm going to try the positive square root of 6 first. Log base 2 of the square root of 6 squared minus the square root of 6 minus 6 is equal to log base 2 of negative square root of 6. Well, this already tells me that the square root of 6 doesn't work because in one of them I have negative square root of 6. And if we looked at the other side, well, this here would be 6 minus the square root of 6 minus 6. So really what I'm left on this side is log base 2 of negative square root of 6. I cannot have a negative inside of the root. Now, if we look at the negative square root of 6, negative square root of 6 squared minus negative square root of 6 minus 6 is equal to log base 2 of negative square root of 6. Well, the negative square root of 6 squared is actually just 6, because the negative times the negative is a positive. The square root of 6 times the square root of 6 is 6. Negative and negative gives us plus square root of 6 minus 6. Log base 2 of negative gives us positive square root of 6. These cancel, telling me that log base 2 of the square root of 6 is equal to log base 2 of the square root of 6. So for our answer here is actually the negative square root of 6 is the right answer for this here. I put this one in here intentionally to remind y'all that just because the value of x that we find is negative does not automatically make it the wrong answer. We have to plug it back in and check and see which one gives us negatives inside the radical. Because if we get negatives, not radical, inside of the log, because any value of x that makes whatever's inside the log negative will not work. In most cases, it does turn out to be the negative, but here, the negative was the correct answer. Any other questions on these here? On 48, 49, or 50?
I'm just curious. I noticed you put a 10 since the natural log base 10.
For these?
Yeah, for 49, it's just said log. So would I put it 10?
So are the logs the same?
Yes. So it cancels out. Yeah.
So we can set what's inside of them equal, and then solve for the value of x. And that'd be our answer. Because it does work out 7 times 5 is 35, plus 3 is 38, and it is a positive number, so it works. Any other questions on these here, where the logs are the same on both sides? We good with these here? Questions on 51, 52, 53, 54, 55, or 56? 52. Is the natural log by itself? Is there anything being multiplied by the natural log? Is there anything being added to it or subtracted from it? Well, the 6x minus 2 is inside that log, yes? So we're wanting to get the log by itself first. So I look to see, is there anything being multiplied by it in front of it? Well, no. Is there anything being added to it really outside of those parentheses? Well, no, it's by itself. There's nothing else to it. So what we can do is, since it's by itself, apply e to both sides because those would cancel, leaving us with 6x minus 2 is equal to e to the 7th. Now, since we know that e is an irrational number, it's a non-repeating, non-terminating decimal, I'm going to leave it till the very end. Now, what can we do next to solve for the value of x? Add 2 to both sides. 6x is equal to e to the 7th plus 2. And then what can we do? Divide by 6. X is equal to e to the 7th plus 2 divided by 6. We should get a pretty decently good sized number. 183? Point what? Yep, and that's it. For some reason I was thinking that number was going to be bigger. Yep, that's it. But that's all we have to do for this here. And again, I would write out and I would make sure that you do have x equals for, if this was on the test, x equals e to the 7th plus 2 divided by 6 written out, not just have the final answer. Because it is very easy if you're not paying attention to when you're typing this in, if you don't get out of the exponent, e to the 7th, if you just do plus 2 divided by 6. Because e to the 7 plus 2 divided by 6 is not going to be 183. It's just not going to work out that way. Because that would be 9/6, so 2/3, so you're actually going to get a number smaller than 2. And I say that just because if you end up getting that really small number, I will know, yes, you actually did it right, calculation error. Does that make sense? So writing out your steps is a good thing. Any other questions on these two here? Any other questions on 51 or 52? Do we feel comfortable with 51 and 52? 54.
So is that 4 being subtracted?
Yep.
We need to take it first.
Yes. So for 54, we'll need to add 4 first. And then we would do e to get those to cancel. Tell me that 6x is equal to e to the 19th. And last but not least, we would divide both sides by 6. Tell me x is equal to e to the 19th divided by 6. And this is, I think, the huge one.
I don't even know how to say it.
29,747,050 and 16 hundredths. I always put the commas back in. It helps me see where the places are. Because when I read it out, I put the commas in and then count over. Thousands, millions, okay, 29,747,050 and 16 hundredths. And that would be our answer. If the numbers get too big and you get an overflow, or not overflow, but E, especially on the graphing calculators, gives you E to the 10 or E to the negative 10, I'm just going to take that. Because on some of them we had, I think it's 7 to the 23rd is one of the answers. I'm just taking 7 to the 23rd. I'm not going to make you write that whole thing out. Because I don't even think the calculator can calculate 7 to the 23rd. Nope, because it has 19 spots after the first number. So it's a 20-digit number. Questions on this here? We good with those here? Okay. Questions on 55 or 56? Yep. Now, because these two logs are being added together, we can rewrite it as one log being multiplied. What's inside is being multiplied. So we'd have log base 5 of x plus 4 times x plus 1 is equal to 2. Then what can we do next? Put both sides to the 5th power. As these would cancel, leaving us with x plus 4 times x minus 1 is equal to 25. Any questions on this so far? Now, the next thing we're going to need to do is we're going to need to factor that there. Yep. We'll need to factor this. So we'll multiply through x times x would be x squared minus x, not minus x, plus 4x plus 4 is equal to 25. Because they're both positive. Now we can combine like terms. And we get this here. Now, because it is a quadratic, we do need to get this equal to 0. So we would subtract 25 from both sides. And these would cancel out, giving us x squared plus 5x minus 21 is equal to 0. Well, we're going to need the quadratic formula. Because if it had worked out to be 4 instead of 5x, 4x instead of 5x, we could have had this factorable. Because we could have used 7 and 3. 7 minus 3 is 4x. Because unfortunately, there's no factors of 21 that will actually give us 5. Because the only ones that we have are 1 and 21, or 3 and 7. So we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And really we're getting our A, B, and C from these here. A in this case is 1, B is 5, and C is negative 21. Now this part here we can start simplifying a few things. Now if we type all of this into the calculator, I believe we should get 109. 5 squared minus 4 times 1 times negative 21. We should get 109. Any questions on this here? Now, in most cases, we would leave this as the answer, or most likely, but the instruction told us to round to the nearest third decimal place, yes? So we actually have to break this up, where we have negative 5 plus the square root of 109 divided by 2, and negative 5 minus the square root of 109 divided by 2. And we'll have our two answers here. Negative 5 plus square root. And at this point here, I would type this all into the calculator. And we get 2.720 as our answer. And if we do the other one, we get negative 7.720 as our two answers. Now again, when we go back and look at what we started with, x plus 4 and x plus 1 were our two terms inside the parentheses, yes? Well, negative 7.720 plus 4, that's still going to be a negative number, yes? If we add 1 to it, it's still going to be a negative number. This one does not work, but 2.720, if we plug it in and check, it will give us positive numbers. So out of the two here, the ones that work is our 2.720. Any questions on this here? If I decide to use one of these on the bonus, you might have to use the quadratic formula, but on the test itself, not excluding bonus questions, these will be factorable. If we have this here two logs being added together, I will have it set up in such a way that it will be factorable. But on the bonus, you might have to use the quadratic formula. Questions on this here? Okay. Questions on 56? Okay. Questions on 57 or 58? 57 or 58? So we want to get the variable outside of the log. So to simplify the log, I'm going to put both sides to the fourth power, which will tell us that x plus 2 is less than 7 to the fourth. Just we want to simplify the log, so we put both to the base of 7. Now to get x by itself, we would subtract 2 from both sides, which tells me x is less than 7 to the fourth minus 2.
When are we supposed to
Whenever we multiply or divide by a negative. If we multiply or divide by a negative, then we flip the sign. Addition and subtraction, we do not. Seven to the fourth minus 2 is 2,399. Now looking at this here, does this inequality include negatives? Well, yes, because -1 is less than 2,399. So since negatives are included, we do have to take what's inside the logarithm and set it greater than 0, because whatever's inside of a log cannot be less than 0. And now we have to solve for the value of x. So x has to be greater than -2. So -2 is less than x is less than 2,399. Now, if it had been greater than, if it said x was greater than 2,399, then we wouldn't have to do anything because the negatives would not be included. Any questions on this here? Any questions on anything we've done so far? Questions on 57? Do we want to look at 57? Or do we want to look at another one? Because we also have 59, 60, 61, 62. Yeah. 59, 60, or 61. So they're one of those that we want to look at. 59. Well, the first thing we want to do is we want to get the natural log by itself. So what's the first thing we can do? 4 minus 7. I want to do the subtraction first before I do any multiplication or division. So I'm going to subtract 7 first, which will give us 53. Then we can divide both sides by 6. Which will tell me that the natural log of x is less than 53 divided by 6. Now what can we do next? We can apply e to both sides, because ln and e would cancel, telling me x is less than e to the 53 divided by 6. Now we're going to leave this alone because e to the 53 divided by 6 is going to be a huge number. Oh, that's actually not that bad. I thought it was going to be worse than that. Because if we write it out as a decimal, it is 6859.11246. I think in the answer key I left it as e to the 53 over 6. Does this include negatives? Is -1 less than 6,859? Yes, so it does include negatives. So whatever's inside the log has to be greater than 0. So we set what's inside the log greater than 0. Now we need to solve for the value of x. Because x was by itself, it just has to be greater than 0. And that's it. That's all we have to do for these here. Any questions on these here? Are we good with this one here? Any questions on 60? Are we good to move on to the exponential inequalities? Questions on 62, 63, or 64? 62, 63, or 64. 63. 3 to the 4x minus 5 is by itself. There's nothing being added to that base or multiplied by it. So what we can do is we can apply log base 3. Yes. 63. Okay. Let's look at 63. I don't know why I heard 62. So 63, e is by itself. There's nothing being added to it or multiplied by it, because we don't really consider the 3x plus 4 because it's all in the exponent. Now, what can I do to both sides to get rid of the e? We can use ln, because our ln and e will simplify out, leaving us with 3x plus 4 is greater than the natural log of 11. Then what do we need to do next? Subtract 4 from both sides. And then divide by 3. So tell me x is greater than ln of 11 minus 4 divided by 3. So x is greater than negative 0.534. Now, because we're talking about the exponents, not logarithms, that's fine. We can have a negative number inside of an exponent. We just can't have a negative number inside of a log. So this here works out just fine. Any other questions on 62, 63, or 64? Or are we good with these here? Any other questions on any of these here? Okay. Let's go back. 50. Okay, so let's look at 44, because we do have some time to look back at it here. So when we look at 44, if we're solving for the value of x, we want to get e by itself first. So the first thing I can do is subtract 9 from both sides, because 9 minus 9 will cancel out and tell me that 6e to the 2x plus 1 is equal to 6. And from this here, we can divide both sides by 6, telling me that e to the 2x plus 1 is equal to 1. And really doing those two steps gives me e by itself. So at this point here, we can apply the natural log to both sides, because these will cancel, telling me that 2x plus 1 is equal to the natural log of 1. And now we just need to solve for the value of x. So the first thing we can do is subtract 1 from both sides. So 2x is equal to the natural log of 1 minus 1. And last but not least, we can divide both sides by 2, which tells me x is equal to the natural log of 1 minus 1 divided by 2, or negative 1/2. So the value of x for this here is negative 1/2. And it works out this way because the natural log of 1 is 0. The log of 1, no matter what the base is always going to be 0. So we get negative 1/2. Any other questions on this here? All right.